This is the second part of the color organization lecture series. In the previous lectures, we have studied about color mixing and theories used in mixing of colors. We learned that there are two theories of color mixings, additive and subtractive. We also learned that additive theory governs the mixing of light and is based on three colors, red, green, and blue. Whereas the subtractive color theory governs the mixing of the color pigment and is based on colors cyan, magenta, yellow, and black, or CMYK. CMY is clearly understandable that they represent cyan, magenta, and yellow. YK is for black. There are two popular logics being associated to this. One is that in pigment mixing or printing, black is the key for shade developing or highlighting. That is why K is used for black, meaning the key color. Second logic is that K is the last digit of the black, and it is selected to be used so that no other color can be confused if the starting letter B is used. In the first part of this series of the lectures, we went through a logical approach of color arrangement or the color organization. We took an example of mix of color stones and we discussed that how these color stones can be separated in an orderly or a logical way. We also had a recap of the color space and we revised our previous concept of color space and also reinforced our concept of CIE chromacity diagram. Now with these base concepts in place, in this part of lecture, we will learn about number one, what is the color order systems? Number two, the history of color systems. Number three, what are most commonly used color systems? And number four, why we need color systems. Now answering the first objective of this lecture, what is color order system? There are several definitions, but here I'll be presenting three most common ones. The first one comes from a technical committee of ISO. ISO stands for International Organization for Standardization. It's the organization for standard setting, founded in 1947. The organization promotes worldwide proprietary, industrial, and commercial standards. According to them, the color order system is a set of principles for the ordering and denotation of colors, usually according to defined scales. The second definition comes from a chemist, Graham Douglas, who worked in color chemistry. According to him, a color order system is a systematic and a rational method of arranging all possible colors or subsets by means of material samples. Once the colors are arranged systematically, they are named according to some descriptive terms or are numbered. The third definition, summarizing the first two. According to third definition, a color order system is a continuous and orderly arrangement of colors and logical system of denotation. अगर आप इन तीनों डेफिनेशंस को देखें तो तीनों डेफिनेशंस दो ही चीज़ों के बारे में एक्सप्रेस कर रही हैं. नंबर वन कि जो कलर्स हैं उनको एक ऑर्डरली अरेंजमेंट्स जो है उसमें तरतीब दिया जाए, और दूसरा कि उन कलर्स को जब एक ऑर्डर में तरतीब दे दिया जाए तो फिर उनकी कोई डिनोटेशंस होने चाहिए, उनके कोई रेफरेंसेस होने चाहिए. इसका मतलब है कि कलर्स की एक अरेंजमेंट हो और उसके बाद हर कलर का एक अपना यूनिक रेफरेंस नंबर हो. आगे चल के हम देखेंगे कि ये कलर्स जो हैं इनको कैसे मुख्तलिफ तरीक़ों से अरेंज किया जा सकता है और कैसे उनके रेफरेंस नंबर्स क्रिएट किए जाते हैं. Now moving on to the history of the color systems. The aim of making order in the vast set of colors that humans are able to distinguish has existed since the ancient times and appears along the whole human history. Among the people who have proposed some kind of color order system, there are famous philosophers, architects, artists, scientists, and writers. For example, Aristotle, Leonardo da Vinci, Isaac Newton, Albert H. Munsell, William Ostwald, Arthur Pope are just to mention a few, have been outstanding in formulating and building color order systems. This task has also been pursued by organizations such as Commission Internationale d'Eclairage, which literally translated International Commission on Illuminations, abbreviated as CIE. I hope all of you remember that CIE chromacity diagram. Other organizations include Optical Society of America, the Swedish Standard Institutions. A color order system seeks to include all colors in a model, giving a specific position to each color and proposing some kind of logic that determines the whole organizations. These models have adopted according to the different authors and along times. The most diverse shapes: chromatic circles, colored triangles, colored solids, and within this last type, the colored solids, different solutions has been offered. Cones, pyramids, double cones, double pyramids, spheres, or more or less irregular solids. Let's review the work of some of these scientists, designers, architects to make our understanding more clear how these color order system developed over time. For example, 350 BC, Aristotle, he developed a theory of color based on observing color in nature. He believed color was perceived through combination of light and a dark. The primary element of color in his model were sunlight, firelight, air, and water. According to his model, colors were made by mixing light and darkness. He thought red was a mixture of sunlight and darkness. And according to him, this explains why the sky turned red at sunrise and sunset, because the sunlight was mixing with the approaching or receding night, which is black color. His basic colors were red, yellow, blue, green, violet, black, white, and brown. In 1704, Isaac Newton presented Newton's color circle with the 7 colors of spectrum appearing around the circumference, demonstrating how mixing the 7 colors of light creates white. Before Newton's time, many of the color ordering systems was presented by different scientists, and in many of those color ordering systems, spiritual attachment with color was also used as the base or logic for developing a color ordering system. Isaac Newton was the first color theorist to approach color from a scientific rather than spiritual standpoint. Unlike his predecessors, he observed 7, not 6 spectral hues, including indigo, possibly basing this on the 7 musical tones. Newton was the one who created the first color wheel. Newton discovered color as a function of light. He observed the spectral hues when he bent light through a prism. Because his color system was based on light, his ideas were somewhat theoretical at that time. He was never able to reproduce all his theories through paint. For example, mixing all primaries together to create white, because the pigment system work different than the light system does. In 1810, Johann Wolfgang von Goethe presented a color circle using the 6 colors of crimson, orange, yellow, green, blue, and violet, minus the indigo that was presented into the system by the Newton. Basically, Goethe reacted against Newton's theories because they didn't translate to mixing pigment. He theorized that color phenomena happened in the human eye rather than in the white light. Goethe observed that under strong midday sun, shadows were black or gray, but that in other conditions, cast shadows were the complement of the hue of the light. This observation was important to the Impressionist painters. Goethe's model of color relationship contained the 6-hue color wheel, and that demonstrated primary and secondary color. He depicted those primary and secondary colors as triangle, and complementary relationship depicted as straight line. Whereas in his model, primary colors red, yellow, and blue were the points of the triangle, and the secondary colors orange, yellow, green were on the inside edge of the triangle. For Goethe, tertiary colors are mixtures of the 3 colors surrounding them. They are nameless, non-specific colors, mixture of red, violet, and orange, for example. In the same era as that of Goethe, another artist, Runge, Otto Philipp Runge, he corresponded with Goethe about the color, and it is a popular belief that he assigned the 3 primary colors of yellow, red, and blue to the famous Christian concept of Holy Trinity. His color sphere was later praised and adopted by the Bauhaus. Bauhaus is an famous art school in Germany. Otto Runge attempted a three-dimensional depiction of color, and he wanted to demonstrate that color was not only a function of hue, but also value and saturation. In his sphere, the equator, the center line was made up of pure saturation colors, and they traveled as tints and shades toward the 2 outer poles, which are pure black and pure white. It means that moving toward the upper pole, the pure hues are converted into the shades, and moving downward pole, the pure hues are converted into the shades. The teachings of the Bauhaus are considered as the foundation for the modern color theory. Color phenomena, simultaneous contrast, relationship, contrast of hues, saturation, value. But it is being thought that there are some shortcomings of the Bauhaus model, and those are that they tend to look at color in a vacuum without considering their relationship to imagery, psychology, or communication. Out of the most popular color ordering system, one was presented by an art teacher, Albert Henry Munsell, in 1905. Munsell divided color space into hue, lightness, and chroma. Actually, he expanded on Runge's three-dimensional color model with his color tree. Munsell basically began his color model with five basic hues: red, yellow, green, blue, and violet. And out of this, he created a 10-step color wheel. His complementary pairing are red to blue green, yellow to blue violet, green to red violet. And blue and orange is the only pairing we recognize from the traditional color wheel. Basically, he developed his complementary pairing from the after image observations. If you remember, we did these after image experiments in the class. I'm sure you remember that flag experiment we did, that we started staring on a flag, on a spot on a flag for some time, and then all of a sudden we shifted over to a blank slide and we immediately observed the reverse colors. This was the concept Munsell used to create his complementary pairings. In Munsell's 10-step color tree, value is represented along the center axis and the saturation is represented across the horizontal axis. The tree is not symmetrical like rest of other color models because color reaches full saturation at different values. For example, the yellow goes far away as compared to some red tone or some violet tones. Similarly, the blue is far less than greens. Munsell's color tree was the basis for the expanded color palettes we work from with digital colors in digital photo making or design making or photo touching softwares, as well as the industrial colors. Now let's learn about the most commonly used color ordering systems. And studying these, we will learn in detail how these color ordering systems are arranged and how color referencing works in these systems. Most commonly used color ordering systems for art and design are Munsell color system and natural color system. Color systems can be categorized into two large groups: color stimulus systems and color perception systems. Color stimulus systems were established in the 20th and 21st centuries. Their developers were almost without exception physicists and information specialists. They were systemizing radiation energy of different wavelengths, creating the experience of different colors. These have been registered for the industry in international standards. The roots of the establishment of color perception systems appear in the distant past. Their creators were representative of the most different professions. There are, among others, painters, artists, architects, writers, poets, philosophers, doctors, religious clerics, chemists, botanists, and many other craftsmen being charmed by the diversified world of the colors. Almost all of perception-based color systems are discontinuous. In most of the systems, the letter or the number notating the color indicates the location of the color in the color arrangement system. The Munsell color system is a color system that specifies color based on three color dimensions: hue, value, and chroma. Basically, Munsell wanted to create a rational way to describe color that would use decimal notation instead of color names. He wanted that every color should have a unique number, should have a reference number that can be used to identify that color. Munsell constructed his system around a circle, arranging its colors at equal distance and selecting them in such a way that opposing pairs would result in an achromatic mixture. The system consists of a cylinder with the value at the axis from light to dark, running up and down through it. Dark colors are at the bottom of this cylinder and light colors are at the top, measured from 1 the darkest to 10 the lightest. With this concept, he constructed a color tree in which the darker colors were at the bottom and the lighter color were at the top. Each horizontal slice of the cylinder across the axis is a hue circle, which is divided into 5 principal hues: red, yellow, green, blue, purple, and they have 5 intermediates: yellow red, green yellow, blue green, purple blue, and red purple. The same is depicted with alphabets in the Munsell color circle. Each horizontal slice of the cylinder across the axis is a hue circle. As Munsell system is using 10 values, so there are 10 hue circles. Now, hue is the color such as red, green, blue, etc. In the Munsell system, these are given letter codes, that is red R, yellow red YR, green G, green yellow GY, so on and so forth. Value is how light and how dark a color is. In the Munsell system, value is indicated with number, that is starting from 0, 1, 2, 4, 6, and so on. The value scale runs vertically and move from lightest at the top to the darkest at the bottom in descending order. So 2 is going to be darker than the 6, and chroma is how weak or strong a color is. In the Munsell system, chroma is indicated with number typically in range from 2 to 14 or upward. In certain cases, it goes up to 30. specifically when the fluorescent color family is there. The chroma scale runs horizontally and moves from weak from the left to the strong on the right in ascending order. So 2 is going to be weaker than the 6. So 2 is going to be weaker than the 6. So each horizontal circle in Munsell system is divided into 5 principal hues, that is red, yellow, green, blue and purple. And along with this, they have 5 intermediate hues. For example, yellow red, green yellow, purple blue. They are halfway between the adjacent principal hues. And each of these hues, this means that every main hue and every intermediate hue, they are being divided into 10 parts. So total 10 hues in the circle, and every hue is divided into 10 parts. So total 100 hues will be in the Munsell system. Now each color is designated with what is referred to be the color notation. For example, a color 5R 7 by 2. This notation refers to these three attributes of the color: hue, value and chroma. So 5R is the hue or the color. 7 is the value. It's either lightness or darkness of the color. And 2 is the chroma. It's telling that if a color is weak or strong. Now if we compare 5R7 by 2 to 5R4 by 10. So 5R, this is the hue 5R. This chart is the hue 5R. So 5R 7 by 2 mean this all is 5R. So 7 and 1, and rather this is the 2. So 5R 7 by 2 is this color. Comparing to this, in this 5R hue 4 by 10. So this is 4 and this is 10. So 5R 4 by 10 is going to be this color. This means that 5R 7 by 2 is less rich as compared to 5R 4 by 10. NCS color, or the natural color system, is based on exactly what the word implies: natural. The colors are exactly how the eye naturally see red, yellow, blue, green, white and black. This color system is commonly used in painting, decorating and designing. As far as the structure of the NCS color system is concerned, NCS is based on 6 elementary colors: yellow, red, blue, green, black and white. The 4 bright colors are arranged so that they form a circle. Black and white form the endpoints, and a straight line passes through the center of the circle. Together, they form a double cone that completes the color space of the NCS color system. All colors are named according to their similarity to the elementary colors. From one color to Next color, there are 10 steps representing the percentages. To understand this, let's indicate the first position of the hue on the color wheel. Say it is yellow. Now with yellow's reference, if we take an example of Y90R, so Y90R will be a yellow with 90% red. The other color properties are black and color saturation. As the NCS color space is in double cone form, so chroma is connected to the whiteness and the darkness diagonally. There are 10 steps between whiteness and the darkness and 10 steps between the chroma saturation. To further understand, let's see if an NCS notation 2050 Y90R. So we already know Y90R mean yellow with 90% red. What does 2050 mean? So 2050 tells us that this is yellow with 90% red, 20 whiteness and 50 saturation. Similarly, if we consider blue NCS 4055 R95B, this means this color has 40% darkness, 55% saturation of the color, 95% blue with 5% red, or 40% darkness, 55% saturation, red with 95% blue. Similarly, if we take yellow NCS 0580 by 10R, this means 5% darkness, 80% saturation of the yellow color. This is yellow with 10% red. So it's mean 90% yellow. Reviewing the next video will give you the understanding of use of color systems and visualization of the natural color system.
Imagine for one moment what our world would be like without colors. Choosing colors should not be a gamble. It should be a conscious decision. Colors have a meaning and a function.
So I have this brown on my couch back home, or like...
How can we make conscious and successful color decisions when there are millions of colors to choose between?
Maybe if we start with this one.
Your customer would like a kind of sky blue that matches a fabric they've already got. But what color is sky blue? And what kind of blue would work really well with the color of the fabric? How do we choose and communicate color?
It's a mix between.
Is there a shortcut to creating a color scheme for an excellent design?
So let's have.
These are some of the reasons that we need a color language that everyone understands. This is why NCS, Natural Color System, was researched and developed. It describes every color we can perceive. Let's take a closer look at how it works.
Looks really good. Yeah. Like it.
In the color circle, you'll find yellow, red, blue and green as the reference colors, or as they're scientifically described, the elementary colors. Let's take our sky blue color and define what we see. First, we need to define what kind of blue it is. We have to find which hue it belongs to. As you can see, a blue color can be greenish, blue only, or reddish. Our sky blue is slightly reddish. It's a blue with 10% redness and 90% blueness. The hue is called R90B, as we read things clockwise, from red to blue. A pure blue would be B only. Now that we know the hue of our color, we need to describe its nuance. All the colours in this triangle have the same hue, R90B, but differences in blackness, whiteness and chromaticness. Our sky blue is not so black, only 20%, but it's quite strong or chromatic, 40%. This means that we have a colour that has 20% of blackness and 40% of chromaticness. It's a red colour with 90% blue, 20/40 R90B. Now we can discuss this colour, and we can choose any colour that exists and place it in this colour space. This is the first important step in colour design, to understand the colour you work with. From here, our intuitive colour inspiration is becoming rational. Let's put theory into practice. We've probably all faced the challenge of finding colours that match. Of course, there are many ways to find colour harmonies. One way is to combine colours that have something in common, for example, a similarity in hue or nuance. You can also match other factors, such as chromaticness, whiteness, and blackness. What happens if you want to use this colour on an exterior? It's important to understand that the colour you choose won't look the same when applied on a larger surface and in daylight. Our colour will therefore look more whitish and more chromatic. This means that when choosing an exterior colour, we need to pick a darker and less chromatic colour. No one knows how to colorize your design better than you. Our intention is to offer you great tools for great color concepts. Visit ncscolor.com/design.